Okay, guys, I've got another meeting on my other computer down in the office, so I'm gonna leave you with Mr. Haddock. Text me if something goes wrong, and I'll run right back down to the classroom, okay? Okay, Mr.
They nod their heads.
Yeah, I think they're scared that I'm leaving you in charge of the computer.
Well, that's a little scary.
Okay, I'll be right back.
Okay. Listen, we had some problems on page 400. Did you have any difficulties with those or not? Would you like to go ahead?
I got confused on like 47 and 48 where it only had Y and not like a Y and an X.
Same.
47 and 40 what?
48.
So it says sketch the region and then calculate its area. Okay. So 47, y equals 4 minus x squared. Is that right?
Yeah.
Yes.
And then y equals 0.
Yeah.
Correct? Okay. Now, again, this is just a parabola. It's been moved up 4 spaces and then turned upside down. So we're talking about this parabola right here. Okay? So that's the equation y equals 4 minus x squared. What's this? Well, y equals 0 is just this horizontal line. So they want you to find the area between the curved line and the horizontal line. So they just want you to find the area there. Okay? So if we find the area, we're going to integrate, and we're going to have one rectangle here. This one rectangle has a base and a height. The base is how wide this is. Well, that's very, very thin, and we refer to that as dx, delta x. It's the distance divided by the number of rectangles, and that's infinite. It's an infinite number of rectangles. And this is the height. From here to here is just the y value. That's all it is. So this area is going to be 4 minus x squared dx. And we're going to integrate that from this point right here to this point right here. So this point is -2, this point is +2. So we're going to find all of the rectangles that fit in this area from -2 to +2. So that's all you're going to do. So don't let this throw you off. This is just the x-axis. It's the horizontal line. So we're finding the area between the curve and the line. And so this is just the y value, and this is dx. So if we integrate this, this is 4x minus x to the third over 3 plus c from -2 to +2. Okay. The integration is just the antiderivative. So if you put in the number +2, you're going to have 8 minus 8/3 plus c. If you put in the number -2, you're going to have -8. And this would be a -8, and a negative here would be a +8/3 plus c. And then you have to subtract those two answers. So after you integrate it, the antiderivative, you put in a +2 for x, then you put in a -2 for x, and then you subtract those two answers. Well, if you have 8 minus -8, that's +16. If you have -8/3 minus 8/3, that's a -16/3. And C minus C is just going to go to 0. So this is just going to be 16 minus 5 1/3. Okay. 10 2/3. So this area is 10 2/3. So you have to integrate it, antiderivative, put in a positive 2, put in a negative 2. Now I'm assuming number 48 is probably pretty much exactly the same thing. It has y equals 2x minus x squared and y equals 0. So if we're going to look at this, what the graph looks like, I don't know what that is. I know it's a parabola turned upside down, but I'm just going to plot some points. So if I put in the number 0 for x, I get 0 for y. If I put in 1 for x, I get 2 minus 1 is 1 for y. If I put in the number 2, I get 4 minus 4 is 0. So I know now this curve looks like this. Okay. So that's 2x minus x squared. And then the line again, y equals 0, is just this horizontal line. So we're just going to find the area between the curve and the horizontal line. So we're going to just do exactly the same thing. If we put in one rectangle, the area of that rectangle is the base times the height. The width is dx, the height is just the y value of the curve. Now this is going to go from 0 to 2. So you're going to have to integrate it from 0 to 2. So if you take the integrate 2x is going to be 2x squared over 2 minus x to the third over 3 plus c. Just taking the antiderivative. We're going to integrate that from 0 to 2. Now this is going to be fairly easy because doing with zeros simple. If you put in the number 2, you have 4 minus 8/3. If you put in the number 0, you have 0, 0, and then c, and then you subtract. So your answer is just 4 minus 2 2/3. So that's 1 1/3. This area right here is 2 squares, and you can see that area is a lot smaller than that, so it's 1 1/3. That makes sense? That line y equals 0 is just that horizontal line. It's just the x-axis. Okay. Any others? Did you have any problems on the integration problems from the odd one from 19 to 41?
31.
31 is cosecant times cotangent. Okay. All I'm going to do is I'm going to look that up because I don't know what it is. And it's on page 403. And the antiderivative of cosecant times cotangent is negative cosine x, or cosecant x. Everybody see that? You just look it up on page 403. And it says the antiderivative of cosecant x times cotangent x is negative cosecant x plus c. And they want us to integrate that from what was that? Pi over 2 to pi over 6 to pi over 2. Pi over 6 to pi over 2. Now pi over 6 is 30 degrees. Pi over 2 is 90 degrees. So we want a negative cosecant pi over 2 plus c. And then we have a negative cosecant pi over 6 plus c. And then we're going to subtract those two answers. So I always put them in parentheses. Okay. So again, the c minus c is going to go to 0. That's going to be fairly easy. This is a negative cosecant pi over 2. And then this is going to be negative times a negative is a positive cosecant pi over 6. Okay. What's the value of the cosecant of pi over 2? Now, some of you still have your calculators. Abby, is Abby here? No, Abby? What's the cosecant of pi over 2? Cosecant is the reciprocal of what?
Sine.
Reciprocal of the sine, okay? Here's the sine curve, right? The sine of 90 degrees is 1. The reciprocal of that is to turn it upside down. So turn the number 1 upside down, what do you get?
1.
1, okay. So this answer is a negative 1. Okay. The sine of 90 degrees is 1. So the cosecant of 90 degrees is the reciprocal of that, 1. And then this is going to make it a negative 1. Well, what's the cosecant of 30 degrees? Well, if you have a 30, 60, 90, the relationship is 1 to 2 to the square root of 3. So the sine of 30 degrees is 1/2. So the cosecant of 30 degrees would be the reciprocal of 1/2, which is 2. So negative 1 plus 2 is just 1. So the answer to 30, whatever that was, 31, is 1. Provided I didn't do anything stupid. Remember, any angles they give you are going to be 45, 45, 90s, 30, 60, 90s, or 90, 180, 360, where you can find the measurements fairly easy. Any others of those on page 400?
37.
37 is x to the e plus e to the x. And we want to integrate that from where to where?
0 to 1.
0 to 1. Okay. What's the antiderivative of x to the e? Because we're integrating. Integrating is the antiderivative. What's the only rule we have?
Exponent divided by that number.
You just add 1 to the exponent and divide by that new exponent, right? So if we add 1 to the exponent, we got e plus 1. And if we divide by that new exponent, we have e plus 1. So that's the antiderivative, because e, remember, is just a number. And then plus, what's the antiderivative of e to the x?
E to the x.
Just itself. Plus c, we're going to integrate that from 0 to 1. So if you put in the number 1 for x, you're going to have 1 to the e plus 1 power over e plus 1 plus e to the first plus c. If you put in 0, you're gonna have x to the 0 plus 1, or excuse me, you're gonna have 0 to the e plus 1 over e plus 1 plus e to the 0 plus c. And then you're gonna subtract those two answers, okay? Well, c minus c is gonna go to 0, okay? 0 to any power is what number?
1.
0 to any power, 0 multiplied 150 times is still gonna be what?
0.
0. Oh, 0 divided by any number is 0. So that's gonna be 0, right? What's e to the 0? Now you got it, what'd you say?
1.
1. Okay? E to the first is just this. What's 1 to any power? If you multiply 1 times any number, times itself 150 times, what are you going to get?
1.
1. Right? So this answer is going to be 1 over e plus 1 plus e minus 1. Not a very pretty number, but that's it. So the antiderivative is add 1 to the exponent, divide by that new exponent. Antiderivative is itself. Put in the number 1 for x, so you'll have 1 to the e plus 1 over e plus 1. E to the first, put in 0. You get 0 over e plus 1 divided by e plus 1 plus e to the 0, which is 1 plus c. That's all that's left. Now, they may have added those together as a fraction in the back of the book, or it's left like that. Did anybody look at it?
No.
Like that.
Number 37. And this is page 400. They have in the back of the book on 37, they have 1 over e plus 1 plus e minus 1. And that's what we have. Okay. Did some people, when you put 0 to the e plus 1 power, did some people put 1? Did I hear that? Okay. Any others? On that page, page 400?
Can you go over 41?
41 is the antiderivative from 0 to 4 of 2 to the s dx.
Or sorry, I mean 8 or 39.
39?
Yeah.
I think it said the square root of 3 to 1 divided by the square root of 3. Is that right? Like that?
Yeah.
Okay. This is just 8. So a lot of people are just going to put this 8 outside. So it's just going to be 8 times whatever this is. Okay. And the only rule that we have is add 1 to the exponent and divide by that new exponent. We don't have any rule that deals with parentheses. So what you have to do, you have to look this up. And the integration of 1 over 1 plus x squared, looking on page 403 again, that's arctangent x, isn't it? I think it's arctangent x.
Yeah, it is.
Plus c. So it's going to be 8 times arctangent x plus c. We want to integrate that from 1 over the square root of 3 to the square root of 3. So you put in the largest number first. So we want to find arctangent square root of 3. Put in the smallest number. We want to find arctangent 1 over the square root of 3 plus c, and subtract the two answers. Well, the c minus c is going to be 0. So the first thing we want to do is that. Okay. Now remember how you read this. Okay. This is arctangent. That's red is find the angle whose tangent is the square root of 3. So I want to find the angle whose tangent is the square root of 3. Now tangent is defined as opposite over adjacent. So I found the angle, it's right here. The angle whose tangent is the square root of 3 is this angle. Well, finishing out this problem, this is 2 by the Pythagorean theorem. The only triangle that has a relationship of 1 to 2 to the square root of 3 is a 30, 60, 90. So this angle right here is 30 degrees. This angle right here is 60 degrees. So the angle is pi over 3. So we're going to have 8 times pi over 3. And then we're going to have minus 8 times whatever this answer is. Well, that answer is going to be 8 times arctangent 1 divided by the square root of 3. Well, find the angle whose tangent is 1 divided by the square root of 3. And that makes this 2. That makes this angle 30 degrees, which is pi over 6. So this is going to be 8 times pi over 3 minus 8 times pi over 6, common denominator, so on and so forth. You got 16 minus 8 is 8 pi over 6, 4/3 pi. 8 pi over 3 over 6 reduces to 4 pi over 3. Make sure we did that right. Number 39. 4 pi over 3. But you got to remember how you read arctangent. Find the angle whose tangent is the square root of 3. Find the angle whose tangent is 1 divided by the square root of 3. Okay? Anything else? Okay, do the same thing with that assignment. Photo it, send it to my address at the school, and then I'll get it there.
Okay.
All right? I think I already got yours, don't I, Sydney? Sid?
I sent it in earlier.
That's what I thought. Okay. Our next assignment is on page 408. It's almost identical to what we did today. I wanted to give you one more deal on that. So let's take a look at a couple of examples that they have for us. Let's look on page 404. Example number 1. And they want you to integrate 10x to the 4th minus 2 secant squared x. And they just want the general, which means you're not going to do any arithmetic. All you're going to do is find the integration. So we're going to add 1 to the exponent, divide by that new exponent. I don't know the antiderivative of secant squared. I'm just going to look it up on page 403. And the antiderivative of secant squared is tangent. So this is tangent x plus c. And then 10 divided by 5 is just 2. So that's your answer right there. 2x to the 5th minus 2 tangent x plus c, stop. You don't have to find the value because they didn't give you any limits of integration. They didn't give you any values to stick in. You're just done. The second example there, example number 2 says evaluate cosine theta over sine squared theta. So they want the answer in terms of theta. We don't have a division rule. When we take antiderivatives, we don't have a division rule. So what we're going to do is we're going to rewrite this. And instead of writing sine squared, we're going to write sine theta times sine theta. So the cosine we just write as cosine times 1 basically, and the sine we write as sine times sine. This is cotangent by definition. If you have to look those up, those are identities from trigonometry. You can find them in the book. The identity of cosine divided by sine is cotangent. 1 over sine is cosecant. And I don't know what this answer is, so I'm going to look it up. Okay. I want the antiderivative. I want the integration of cotangent times cosecant. I'm going to look on page 403. And cosecant times cotangent is negative cosecant. So this is negative cosecant x, or theta in this case, plus c. So you just manipulate. So we can use that table on page 403. On that table on page 403, there's about 16 or 17 formulas on that page, right? In reality, when I was in college, we had a little pamphlet that had 650 formulas. And so when you had to look them up, you had to look up whatever you needed to look up. You looked up in that book of 650. So there's a lot more than just that, but that's what they're just starting you out with. Okay. Example number 3 on page 404, integrate x to the 3rd minus 6x. And that goes from 0 to 3. So it's x to the 4th over 4 minus x squared over 2 divided by 2 plus c, integrate it from 0 to 3. Okay. 6 divided by 2 is just 3x squared. So if you put in the number 3 for x, you get 81 over 4 minus 27 plus c. If you put in 0, you get 0 plus c. And when you subtract, you get 20 and a fourth minus 27. So 20 and a fourth minus 27 is negative 6 3/4. That's a negative answer. This is not an area problem. If this would have been an area problem, the answer has to be positive. But integration itself can either be positive or negative. So that's what we have there. Example number 4 goes from 0 to 2. And you have 2x to the third minus 6x plus 3 over x squared plus 1. Dx. So they want us to integrate it, add 1 to the exponent, divide by that new exponent. This is 3 times 1 over x squared plus 1. The integration of 1 over x squared plus 1 is arctangent x. So this is 3 arctangent x plus c from 0 to 2. This is just 2 over 4, which reduces to 1/2. This is 6 over 2, which reduces to 3. So when you put in the number 2, you're going to have 2 to the 4th is 16 over 2. Minus 3 times 4 is 12. Plus 3 times arctangent 2. And then when you put in 0, this is going to be 0, 0. And then you're going to have 3 arctangent 0 plus c. The c's are going to cancel out again. And so you're going to have 8 minus 12 is negative 4 plus 3 times arctangent 2 minus 3 times arctangent 0. So what's this answer? This one says find the angle whose tangent is 0. Now, if you don't know, you still have your calculators. So all you have to do is just put arctangent 0 on your calculator. If I remember right, I think you're going to get 0, aren't you?
Yeah,
Yes.
0.
0, okay. So this is just going to be 3 times 0, which is 0, okay? I don't know this answer either. So what's arctangent 2? Now, there's no degree symbol here, so you definitely need to make sure that your calculator is set in radians. So it's better check to make sure that you're set in radians. That's probably Joe. What the heck do I do? Anybody know?
Is there like an accept? Like, do you have to accept him into the chat?
Is there an accept somewhere? Where do I look?
I don't even know.
Can you guys all hear me? That was
Yeah.
probably Joe, I'm guessing. I don't know how Can you hear me, Lane?
Yeah, I can hear you.
Okay. Did you find out what arctangent 2 was? Probably a decimal value, I'm guessing.
1.1.
Pardon me?
1.1.
Okay, 1.1. So this is -4 plus 3 times 1.1. So it'd be negative, what, 0.7? Okay. So we're going to meet again Thursday. Mrs. Jensen already has that set up. So for Thursday on page 408, I want you to do the problems 1, 2, and 3. And then the odd problems 5 to 43. Joe's on here somewhere, but I can't get him
Oh, Joe,
up there.
okay.
So just, what do you do? What do you do?
Okay, let me look and see. Okay, Mr. Haddock.
Well, it went buzz, buzz, buzz,
Yeah.
buzz, buzz. It sang a song.
Okay, there we go. Are you guys on?
Yeah.
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 Joseph, are you on now?
He's getting up.
Okay,
Okay. So page 408, going to do 1, 2, and 3. So I want you to look at those specifically. On page 408, 1, 2, and 3. It says to verify that the answer is correct. A simple one. They take the antiderivative or the integrate, they integrate this problem and they get this answer. On problems 1, 2, and 3, they want you to verify that this answer is correct for this problem. How do you verify it? How do you prove that the answer you get by integration is correct?
By taking the derivative of that answer.
Okay, so if I take the derivative here, 4x to the third over 4 minus 12x squared over 3 minus 6x plus 2 plus 0, because the antiderivative or the derivative of c is 0. So this is x to the third minus 4x squared minus 6x plus 2. That's what you started with. This is supposed to be a plus, by the way. Okay? So that's how you verify it. Take the derivative of the answer and see if you get back to the original problem. And then from 5 to 43, you're just going to do exactly what you did today. except there's going to be more problems that use those formulas on page 403. Okay? So send this assignment, page 400, send this assignment in as quick as you can. Okay? I've got everybody's first assignment now except for Matt and Kylie. And Matt's going to try it again. If you can take a picture of it with your phone, Matt, and send it to my address, lhaddock@parmaschools.org, should be able to get it. Okay? Everybody doing well? Jordan, you're not as sick
You
as you were last week?
Yeah, I don't know what like bit my eye, but it was so swollen. It was so bad.
Okay, everybody's healthy other than that, I hope?
Yep.
Yep.
Okay. Thank you, guys. We'll see you Thursday, same time.
All right.
All right.
Okay. Thanks for showing up, Joe.
You're welcome. I'm glad I came.
Yeah, I'm sure you are. You are smart, Alec, always have been. All right, we'll see you guys. Thank you.
Yeah.
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 Are you good, Mr. Haddock?
Yeah.
Okay,
Thank you.
yep. And then,
I can get Parker